What's up, guys? In the very in the very previous video, I explained you why haloarenes do not react with the nucleophiles. So there was 4 reasons I gave you that haloarenes do not undergo nucleophilic substitution reaction, and it's because of the 4 reasons. Those 4 reasons were due to plus R effect, due to partial double bond character, and due to instability of the phenyl cation, and due to the conflicts between the electrons of nucleophile and the haloarenes themselves. So what that means, if they do not undergo nucleophilic substitution reaction, so what it also means that they will undergo electrophilic substitution reaction very easily because they are electron rich species. So let me write this statement here. Haloarenes being electron rich easily undergo electrophilic substitution reaction. Electrophilic substitution reaction. So now this will be going to be really very simple, right? Because they are electron rich. Because they are electron rich, so they prefer to react with electron deficient. An electrophile is electron deficient. This is an electron deficient. And they are electron rich here. So an electron rich easily react with the electron deficient. That is very important here. So what are the reactions that haloarenes go? The first reaction I'm explaining it is halogenation of this is like nitration of haloarene. Nitration of haloarene. So what this is, you have a haloalkane. Let's take this one. This is, you have a chlorobenzene here. And when you react chlorobenzene with HNO3 in presence of small amount of sulfuric acid, what happened? This contain 2 ions. One contain NO2 positive and other contain OH negative. If you remember that these haloarenes, what happened? All the hydrogen right there. You have hydrogen here, you have hydrogen here, you have hydrogen. There are 5 hydrogen. So what will happen? This hydrogen will be substituted by the nitro group. So one electrophile is substituting another electrophile. So the first product is going to be chlorine right here and then nitro right there. But another thing which is very important, if you remember, all the haloarenes exhibit plus R effect. So what that means, that during the resonance development, they bear negative charge on the ortho and para position. So therefore, the nitration will not only take place on the ortho position, which is first and second. This is your first and this is your second. It will also take place on the first and fourth. It will also take place on the first and fourth. This is your first, then this is going to be your fourth here. Right? So this is going to be major. This is going to be minor. Why this is major? Because this is very symmetrical. However, this is not. So this is what nitration of haloarene is. The second one is going to be sulfonation. So how sulfonation takes place? Again, you have to take a haloarene here. Like I'm taking chlorobenzene, and if you react it with sulfuric or oleum H2S2O7, this reaction, it has 2 ions. The first, it has 2 ions. One is HSO4 negative and other is SO3H positive. Remember, an oleum has 2 ions, hydrogen sulfate and sulfone. So the hydrogen on the second position and also on the fourth position, they will be substituted by sulfonic group. So this will be substituted by sulfonic group, and therefore the two product that's coming out to be, there you have your chlorine. Now there will be sulfonic SO3H. What another product going to be? There you have your chlorine, and there you have your sulfonic group. So this is again going to be major, and this is going to be minor. So this is how sulfonation of haloarine takes place. Now it's time to take you the third one. The third one is, chlorination or halogenation. Halogenation. This is your third one. So let's take example here. Suppose you have a chlorobenzene right here, and if you react it with chlorine, remember one thing, all the electrophilic substitution reactions are carried out in presence of a Lewis acid. So you have to use a Lewis acid like AlCl3 maybe. I will tell you in some other time what is the role of this Lewis acid, because this involves a complex mechanism. So I'm not going to confuse you right now. Right now I will just say that all the electrophilic substitution reaction take place in presence of a Lewis acid. So this is one of the Lewis acid, you can remember. So what happened? Now chlorine will go on the second, or it will go on the fourth. Sorry, second is not there, it's there. So now you do understand what the product is going to be. So this is going to be chlorine 1 here up, another going to be here. But in the next product, which is going to be the major one, you have one chlorine up there, the second one is going to be here. Like earlier I said, this will be minor because it is not symmetrical, and this is going to be major. So this is a symmetrical product. The fourth one, from the board exam point of view, is very important, and it's called Friedel-Crafts reaction. Friedel-Crafts reaction. So what this Friedel-Crafts reaction is? It has two parts. One is called alkylation, and other is called acylation. The other one is called, let me explain you the first one. The alkylation is about when a haloarine like chlorobenzene react with a haloalkane like CHCl3, or I should also write like a haloalkane like RX, in presence of AlCl3, this produces, so you do understand that X here is negative part and R here is negative. Similarly, the hydrogen here will be a positive part and carbon will be negative. So what I'm going to do, I'm going to place one chlorine up there and alkyl group, which is the R right there. So this is the first product, and you do know that this is going to be minor. What next is going to be? The next product is going to be major, where chlorine will be right here and alkyl group will be right here. So this is your major. So this reaction is called Friedel-Crafts alkylation reaction, where the R can be any alkyl group, methyl, ethyl, butyl, or whatever you have to say. Sorry for that. So alkylation refers to removal of hydrogen and substitution by an alkyl group here. The second one, acylation. So what happened in acylation? A halobenzene like chlorobenzene, when react with acetyl chloride, this is your acyl chloride here. So this is, let me write this here. This is your acyl chloride. So there are two parts here. This will be a negative part and this entirely will be a positive part. So what happened? The hydrogen will be replaced by this part. So the product is going to be, the first product is going to be chloro, and there it will be acetyl group. And similarly, there will be another product here. Can I write it there? Because I don't know if it's coming like inside the frame or not. So this is what the second product is. So this is going to be a minor. This is going to be major.